So subspace of Rn, intuitively, what does it mean to be a subspace of Rn? So say you have a 3D space. Then a subspace is another Rm of a lower dimension within this Rn. So it can be a zero dimension, so like a point. It can be a line that pass through here, or it can be a plane that goes like that. Or it can be the whole entire space. Now let's give the formal definition of what a subspace is. So set V as a subset of Rn is a subspace if it satisfies two conditions. One, the vector 0 is in Rn. Number two, V is closed under addition and multiplication by scalars. And what this means is that, i.e., if if A, B vectors in in V, that and also scalar C in R, then we always have A plus B in V, and also C times A in V. This is component-wise addition, and this is component-wise multiplication. So now, and also this is equivalent to if X, Y is in V, and A and B is in R, then we have any kind of linear combination AX plus BY. It's also in V. So now let's get some example. So again, revisiting what we said before, if you have a 3D space, so obviously the set that just contains this, so number one, the set 0 is a subspace because, well, it contains 0, and also it's closed under addition and scalar multiplication, which doesn't mean anything because you only have 1 point. And then if you add or multiply by scalar, you still get 0. So that works. Or you can have the entire R3. So you call this the trivial subspace because it is trivial. And the entire R3. So this whole space is, by the property of a Euclidean space, it contains 0 and it's closed under addition and scalar multiplication. So that works. Number 3, as an example, you can have basically the xy plane. And it contains 0, and also if you have two vectors like this and you add them by the parallelogram rule, then this vector is obviously still on this plane because this plane is sort of like an R2. So we'll sort of say this is the R2 formed by x and y axes. And more generally, any plane passing through the origin, you can similarly prove that it's a subspace.